Okay, hello, welcome to the second design review of today, machine learning. So, model fit. As I was explaining to people, I have been keen to actually use this recently. Um, in fact, I could even pull up some data and try it. I had forgotten this mechanism. So how does this mechanism relate to plot fit arrow blah? You can do plot fit arrow exponential model, right?
Yes.
Well, yeah. I've been talking to Nirmal and if everything goes well today, I'm gonna merge this in master
Okay.
today, and this stuff is
Okay,
gonna
but so
gonna
then
be
our
available.
preferred mechanism for plot fit will be plot fit arrow exponential model open close rather than plot fit arrow quote exponential. True statement or not?
I
I,
mean, one is gonna be an alias for the other, ideally.
I understand that, but I'm just saying what is our preferred thing? What do we want people to learn? I think we want people to learn these model specifications, not
I
to
kind of
tell
think so
people
too,
strings.
because they can actually be documented in a reasonable way with some depth.
Yes, that's what I think. So I think that's the primary thing. I mean, the other thing might work just as a courtesy, but this is the primary thing.
Yeah,
In fact, I even think that we might have some autocomplete if you type in quotes exponential that sort of offers an autocomplete to exponential model. Does that make sense?
I see. I don't know if it's possible, but I'll ask
No,
around.
I'm sure it is possible. I mean, I will tell you that my experience with positional percent has been that this mechanism where you type something in and then you type a percent and then, well, if I did a 1+1 here or something, if I type a percent, I just find it really natural to now hit return to get that.
Yeah, I also
And
use it a lot of times.
right. So I mean, I think this idea that there's something which is sort of the preferred embodiment that you get by hitting return is a good deal. And if we did that with the quote, with those strings, I think that would be nice.
I see. Yeah. By the way, we do support strings in the second argument here. So if you say model fit data comma string exponential,
Okay,
you know
well,
it's the
fine,
same. So they are
fine.
like kind
All
of
right. I mean, I think there's some UX around this that would be nice. I don't know whether it's essential for the first version, but it would be nice.
yeah, this was put together by me. There's very little of it. It's basically the idea is that you get some the core information you get immediately, and then you can query it to get more.
I'm sorry, we're talking about these reports or what?
Yeah, and you're talking about the UX of this, yeah,
No, I was talking
or
about the
something
UX of
else.
the inputting stuff. Do we have
Okay,
design
okay.
folk here? Because we're going to need to look at graphic design of this.
I don't think so.
But then
No,
please get somebody like Jeremy, for
this is the
example, or
information. Yeah,
whoever.
I pulled
Yeah,
it
I
from
understand, but
information.
it needs graphic design.
No, I understand. I'm just
I'll see if
telling you
Jeremy can.
where the asset is coming from. Okay.
Um, okay, so let's just review what we have to review. Okay,
Okay.
first of all, I'm hold on. Just okay, so this will say ANOVA model and so on, right?
Right.
Yeah, we need to decide how to package it. I mean, I put it here so you get also a picture of like where we are going, not just where we are now, because we need to keep in mind the like an evolution patterns of this
Yes,
of the
I
framework.
completely agree. I
We
said
need
that last
like
time.
at least couple of versions.
Right.
But yeah, we basically arrived at the models. So we look at the fact that the first few sections here that you can do the direct training. We decided not to do the one argument form for now, model
I
fit
know.
of data,
Yes, I know.
while
But
we think
that's a
about how
very
to package it.
important thing for us to
We
hit.
we yeah, but we it has to be good, Stephen.
No, I agree. But now the question is what the second argument, which is sort of the automatic model selector, do we end up with a thing called automatic model or something that literally is called?
You suggested that, but I wouldn't go there now because it
No,
pertains something we don't have for this
I
version.
understand. I
Yeah.
understand that. I'm just saying
Mhm.
that, there's a bunch of things one can specify within the automatic model. Do you understand what I'm saying? Where to look, how complicated it should be, etc. What the cost of complexity of the model should be, blah, blah, blah. Does
Yeah, I
that
mean,
make sense?
hopefully the most direct way to do it is what we currently have in the second argument, where you can put entire families if you want, and you
Um,
can clearly specify you want to try this type of model, the other type of model. you want to do cross-validation to find out, the maximum depth of a tree or a neural network or the degree of a polynomial. And we're going to have more advanced sampling, but yeah, that's all something that you can put in the second argument.
Okay, so what are we reviewing
break out of
today?
simple
We're
training.
reviewing the form of this, and I really like somebody from design here.
That you suggested, like a short thing that was from the other meeting. You suggested not to do something particularly smart for the model short name to put into plots and things. So I put here this cross-validation chart, which we like rotated according to your suggestion at the end of your notebook. And now, if you hover over those tick labels, exponential power, you see that outside of the plot, you see this one doesn't have anything. But if you go over the polynomial one, you get the degree and everything. So this is going to be in basically everywhere. Like if you use it as call out or labels. So we might think about something more, I don't know, more informative.
Look, you know what? This is a design problem, graphic design problem, right?
Yes.
And that means we need, you should have set this up. I mean, also something like this is so full of garbage. I mean, this is just such a weird. Okay. Next point.
This is no different from before, yeah?
I know, but it's terrible. Okay. I mean, I don't know whether we should be using round numbers or something like that, but anytime somebody says, I fit this messy data and my fit is 132,869, it's just garbage, right? We all know it's garbage, right? There's at most 2 digits of relevant precision there. Am I making sense?
Yeah, I'm not super familiar with the science of errors in this is the error term, yeah. It's not, I mean, the main fit is.
I don't care what it is.
9.
Look, here we go. See this 0.233166. Okay. That's an over specified thing for a fit.
It's machine precision. So it doesn't really
I know
do anything.
I know. I'm saying this is, it is confusing to see these fits to such high precision.
So do you want to define sort of a print form for this or what?
Possibly, yes.
Because I don't think we should change the numbers.
No, I kind of agree with you. I think it's probably a print form question. But you understand what I'm saying?
Yes,
it looks really simple.
Yeah. I do. And if you know, inside, for example, the standard form of the model with the typesetting is already taken care of. When you extract the expression, now this is standard expression typesetting.
I see. Well, what does it look like inside the model?
Scroll down and open one inside.
Well, I mean, this one here is much more simple.
Exactly. Yeah, exactly. This is how it is done for every model now.
I see. Well, if you extract it, you probably don't have a choice.
Exactly. If I extract it, I don't put any wrap around it. It's just the expression. So wherever I control it, we use a sensible number form.
All right. Okay. So let's just review what we have to review because we've got more stuff here. So what is this?
This is a generic model syntax. We already stopped last time. So basically, all the models, they follow the same syntax, which is hyperparameters, parameters, and variables. Now, this is valid for all the models, even the ones that don't have hyperparameters. You can always put none. I mean, it's not documented, but it's going to work. You can put none or an empty association. Parameters are in general, yeah?
Okay. Are we really going to use up the word model for this?
No, model doesn't exist. This is stands for any model.
No. It means XXX model. It's just a pattern, Stephen.
Yeah.
It's just, see what I'm saying?
Okay. All right. Okay, fine.
Exactly. It's not any specific model. It's like all the models are like this.
No, absolutely not. We're not going to use
No. We are not. Of course, you're not hijacking model.
Okay. So then, what are you showing me here?
So I'm just showing you
that's just a generic pattern. So for any XXX model, this is the arguments that can be there.
Okay, so what is it for example, an exponential model?
Yeah, an exponential model has no hyperparameters. So by default, the first argument is variables. In this case, I say exponential model X. And this gives me that. And if you say exponential model of, AB list, X, you get instead of C1, C2, you get the opposite one.
I don't understand this. I
Parse
don't understand
vars.
Is it
Parse vars.
is an optional? Is parse is optional. I'm matching the convention that we have in nonlinear model fit. We looked at this last time. You were
Yeah,
kind
okay,
of
fine. But I'm asking the question, this is a named variable.
Mhm.
Okay,
Yes.
I'm confused here. Is that name significant? What color will it be when it's in syntax coloring, for example? Is it scoped? What is it?
No, this is using the same as dsolve or whatever. Like
It's
not
not
colored.
scoped.
It's a
It's
dummy
not,
variable.
but it's
Okay,
not
so
scoped.
if I want to plot, let's say I have exponential model of 2, 3, x here, okay? And I want to plot that function. How do I do it?
You apply to something.
Okay.
You do plot
to
of that.
X.
Yeah,
Right,
or X or Y. Yeah, I mean, this is giving you a value, yeah?
Okay, so I would say here of X. And I
Exactly.
would say this, and this is going to fail. Watch this
Yeah,
fail,
it's gonna
guys.
fail. Yeah.
No, it's just
Watch
going to be a
this
bit slow
fail.
because it doesn't optimize much.
No, it's
I
going to
think it's
fail.
gonna fail.
Why?
Because it's going to substitute in that X.
Oh, yeah. I mean, if you put another dummy thing, it's going to work, yes.
Yeah, but that's not good enough, right? Because that's exactly why I was raising the question of scoping. What does that variable mean, other than just decoratively?
Nothing.
So if I do this,
Do comma one. Do comma 1.
no, what's this? Why didn't that work?
Yeah.
Oh, yeah, because now 2, 3 is the variables. I mean, this is that you remove one argument, yeah? We don't have optional variables. We have optional
Okay.
parameters.
No, this is
And that's for a good for a good reason, because in general you don't want parameters. You want
what are we talking about? What are we talking about here? Look, if we're talking about, let's say this is a model. Okay, so this is an unset model, basically. Exponential model of, well, I don't even know what of 2 means here. Exponential
two
model
variables
open close.
by default.
Okay, exponential model open close, right? That is an untrained model, effectively.
Exactly, which means 2 things right now. Untrained.
So why am I not getting a message of some kind here, rather than just doing something stupid? Right? This should generate a message. If you try to evaluate this, I think
it is. Do it outside.
No, it's not.
Should give. No, it's giving a failure. Oh no, yeah, because this. No.
What
okay,
is this? What is this?
This
is
some
wrong.
No, wait a second. This is some courtesy that we have in, because a lot of times you want to try to evaluate things. So if you don't put, if you have, for example, a polynomial model of degree 2,
we're syncing here.
Yes.
This is not that we're syncing. This is a mess.
This is inferring. This is like, it's doing like neural networks is doing. Is inferring the number of arguments from what you put inside. Yeah. If you put it in a
let's take
list.
it from the top. Take it from the top. Okay. Exponential model open close is an untrained exponential model. How do I train that model? What do I do?
You put into model fit.
Okay, so I say model fit of, let's say, random, real, 10, 10, exponential model.
Exactly.
Okay, that returns an exponential model. Okay, if I look at the input form, I get an error message.
No.
It's pilot.
Yeah, okay, it's a front end one. Okay.
Yeah, okay. So then now this model, if I say plot %13 of x, x 0 to 10, I get a result.
Yes.
Okay. So where did that x come from?
That's a dummy. That's formal x is a dummy variable.
Okay. So now
you can specify. You can say, because this function model inside this function model, if you put a y, for example, or var or x, that becomes your variable.
Okay. So this, okay, so let's take this, and now I'm going to do, oh God. Wait a minute. How do I get the report on this thing?
The model fit
I
function.
do information on that.
Oh.
But you don't get the data. No, we decided early on in the preview to separate. The model doesn't have data information. If you want to extract the annotated version, you ask for a report while you fit.
Okay, by
Because
the way,
the model
this
is lightweight.
hold on. This should be formatted correctly with the numbers at the right, just right precision.
Yep. Okay. Yeah, I forgot about that place. Yes.
Okay. All right. So now,
Noted.
how do I get that report from the polynomial model here?
No, you cannot, because you don't have the data. We can think about, because the point is that report is a report about the fitting. We can imagine, if you want another function that gives you a report of, like, kind of classify a measurement that gives you a report of associating a model with some data. But right now we haven't.
First point about this, okay? Get rid of this stupid trained whatever it is thing here. That's extremely obscure. Nobody cares how long it took. We don't give that, we say 2 + 2, 3 microseconds. No, we don't say that. Just get rid of that. It's irrelevant. Why are we even including that?
Well, because you might care when you have more than one.
Just get rid of it.
Yeah, you can remove it.
Okay, let's take a look here. That's not the right thing. This should say polynomial model of 3 here, right? I don't care about the mouse over. If this is a report, just say what the frigging model is.
Well, you could have like 4 or 5 hyperparameters. That's going to be big. I mean, the generic form of hyperparameters is the association. That's going to be polynomial model association degree goes to 3. In this,
okay. Then say
this is why I had a short name with the just values, but you didn't like that last time.
No. I mean, just say it here. If there's things to say, list it down here. This is a report. You can list it. You see what I'm saying? I don't know what all the cases are, but figure them out. And then what we probably want is something that looks more like model. And then, so you're saying this form could be complicated, right?
Well, do information of decision tree model, for example, open close. Just to understand, something that has more hyperparameters. See, this one has 4, for example. Here I'm like formatted them nicely in a grid.
This is
I could do the same.
Okay. Such a mess. Don't say icon. It's an icon. Of course it's an icon.
Yeah, but the information doesn't support not having stuff there.
Well, then fix it.
Okay.
Okay, what does name mean? Why isn't it model?
That I think is an inconsistency that I
Yeah, it's wrong.
Inconsistency.
Right.
Name is a property. Name is a property of the model.
It's wrong. Okay. So, many points here. First of all, let's make this not a capital P polynomial. Okay. So then it is just the name polynomial, not polynomial, a function called that. And like here, just make it decision tree, lowercase decision space tree.
Yeah, understood.
Okay. Now, what does this icon mean? Is this icon significant or is this icon just decorative?
Right now it's decorative. We have a plot version of it if you train it, which is going to be the real one. This is untrained, so it's just a hint. Okay, it's the same one you use in the standard form.
Okay, the first point here, this is an untrained model. Okay?
Yeah, so it's written at the bottom, trained false.
That's a really bad place to put it.
And it's also gray versus blue. You get different color for the trained one. You can see that in the polynomial model below. And it's also in the standard form.
Where's the blue? You mean this?
No, you see it in the plot.
I know the plot is blue and the plot is gray. Great.
Exactly.
That's a really great indication. No.
Well, we use it in several places in the language. I didn't come up with that, but yeah, okay, we can
No,
find
I mean,
better
it
ones.
depends on what one's doing. I mean, in this case, this thing which says icon is driving me crazy.
I understand. I mean, Tally re-implemented information panel to get rid of that, but just the information is a system function. I don't want to touch it. I mean, I can open a
Obviously,
suggestion.
we can just have a null string there. You can deal with it.
Yeah, but it's going to be aligned in a terrible way. But
Okay,
yeah, I understand.
solve the problem, right?
Yes.
We don't have
Okay.
to talk about this.
I can drop the icon. It's not a big deal. We have it in the standard form.
What standard form? In here?
Yeah, you see that is the same. You know, it's a hint. It's an icon that gives you a hint about what's in there.
But what's the icon in the case where it's untrained?
It's the same one that you see in the information. I mean, do it. Polynomial model open close. It's just like a random polynomial. It's gonna be is fixed, of course. It's not gonna change, but
I think that's reasonable, the untrained one there. Although I would prefer, what we do with an untrained neural net.
You look at that. It was like saying unevaluated. You say this is kind of oldish. I don't like that.
Yeah. I think there's a better hint there. Maybe Jeremy, who joined, could make a comment on this. I mean,
For
this is real
case?
data.
This case
is real data, correct? Right? That's an icon of real data. Okay? This case here, where there is no real data, and this is just kind of a decorative polynomial, what do we do?
Is there a textual description that makes sense? Is it equivalent to trained false?
Yes. But
here, trained false is up high and kind of is in the right place. I think the other was buried at the bottom.
What do you mean? Where's trained?
I mean, so you could have. Okay,
what the hell is
pencil.
this? That's garbage. What is that? What is that? Julia, what is that?
That should say automatic. In general, it says automatic. That missing fall through. Because
why don't all of these, when it's untrained, just put a dash, just put a missing dash here? Because
the missing typically becomes dash. I mean, no, the degree automatic is not a dash. If you don't specify the degree, it will look for it using cross validation. So automatic is the actual value that you had there.
Yeah, fine, but this thing, okay. How would one indicate something that has just not been set? We have that in neural nets. If we say something like, linear layer, open close, we get this, uninitialized.
Maybe that's what it should say, something like that. I mean, that's a very long word, but
yeah.
Unfit, not fit.
Unfitted.
Yeah.
Well, see, I think it should be I think having some pink rounded corner thing will be a better idea here. Does that make sense? I just think this is really confusing. It's too close to something real. Make sense?
Can I quickly show you side by side? I have a notebook with the
send it to me.
All of them.
Send it to me, please.
Okay, I'll just copy all of them in a way that you can see them. Okay.
Send it to me, please.
Yeah, I'm saving it and sending it.
Okay.
Okay. Okay, sent.
Roger, you're going to get an invitation to the meeting right after this. Please be there.
Sure.
Okay, so I copy pasted that. This is to basically the input and the output. Yeah, you see the input, it contains a bunch of families with a automatic
These are inputs here.
values. Exactly,
Right?
and they are
These
all gray,
outputs there.
and those are all outputs. So they have the blue thing, and they're like multiple of them because, for example, the nearest model we fit a variety of k nearest neighbors, for example, and the
So I
polynomial.
assume you're going to elide this if it gets ridiculously long.
Yeah. See the last polynomial model. This is using short. There's
Wish we could modernize
angle
short.
bracket.
Can we put? I don't know who's project managing here. I lost track. But can we put a meeting? Probably it should be part of LCC to talk about the formatting of short.
Yeah, I can send that.
Okay. I mean, it's been the same for 38 years. I think we can modernize it.
And also those ifs, shouldn't those be piecewise? I mean,
Yeah, you suggested that, and I tried that, but for this level of nestedness,
Yeah, it's not very good.
piecewise is actually very slow to format as well, to typeset.
Well, that's a different issue which you should look at. Somebody should look at. Okay. Okay. The point here. Okay, so I think these. Jeremy, do you have a good idea for this? I mean, these things.
I don't mind pink. I mean, so we've done dotted as well, and you could dot either just the icon or even the blob itself.
I see. You mean dot this line here?
Definitely, this could be dotted. I mean, optionally, you could dot the outer.
I see. But what about the actual curve?
I think if it's dotted outlining, you don't have to worry about the curve. I mean, we could add the pink, but I mean, I think the dotting helps.
Okay. Here's another possibility. Yes, in fact, this is a good idea. Instead of showing one curve here, we should show several. See what I'm saying? Because it isn't determined which one it is.
Small. Look at the linear model where I sum 3 curves. It's already super noisy visually. The one next to it. The second of the first row. I mean, like
we need
maybe
something which
Jeremy can
indicates multiple
suggest, but
curves, where there's.
Yeah. I'm afraid that it's not going to generalize for all type of models very well. While a more consistent indicator that can be the same across all the models.
Well, I mean, this may not work either unless we test it. What about if you make the curve fuzzy? Smear it out.
Yeah, I think it won't look right.
Like thicker and paler?
Yes. You mean like a gray,
Yeah.
just a big brush stroke.
Yeah. Kind of like filling between 2 curves, but just make it look smeared. Yeah.
Jeremy, any comments on that?
I'm worried it's going to look like a bug, like a rendering bug. I'm not sure. It definitely could get lighter.
Yeah, I
so
don't
it could
know
be much
either.
more subtle. It almost feels like it's, it's done on purpose this way. It doesn't look disabled right now.
Okay, let's lighten it. Let's put dotted dots around it. And then we could try some other things like dotting the curve itself.
Okay, I probably talked to Lou or Itai because this is standard summary box. I don't know how much without touching the framework I can interact with it, but I'll figure it out.
Okay. All right, let's keep going here. So here,
Yes.
What is a hyperparameter instead of a parameter in the context of?
So the hyperparameters are what basically pick a specific model in a family, like a polynomial model of degree 4, a decision tree with a maximum amount of splits, a neural network with 10.
So if I say polynomial model of 4, that 4 is the hyperparameter.
Exactly, because that's not going to change during the training.
When you say, okay, but now the 2-argument form, so I understand this 1-argument form. What is variables doing? Why do we even name a variable here? What's the point of naming the variable?
Two reasons, basically. One is if you want to refer it in another place. for example,
How can
if
I
you have
do
a
that? It's very poorly scoped.
but this is a generic framework. This is always, every model is going to work the same. So if you want to refer to it, for example, in a linear model or non-linear model, or let's say that you have, for example, we are not for this version, but we're going to have like additive models where each
What do you
different
mean by
variables.
refer to it? Where am I referring to it?
Linear model of time, like cos x, comma sine x, comma x. I have an example in the that you can study
Okay,
this.
so you're doing that in order to untangle the fact that those are dummy variables, because these are in fact dummy variables, and they should in this
Yes.
case be green, right?
We don't do that in fit and find fit.
Well, we
I
should.
don't know if there's a reason, but we don't
should.
do it.
We
We
should.
don't do
We've
it in
just
ND solve in.
No, I know we don't do it in ND solve. That's because the variables hang out in the end. Whereas here, there's no variable hanging out. This thing, the fact that that is named X, other than for display, is totally irrelevant. You see what
Okay,
I'm
I see
saying?
your point. I see your point.
It's like
Okay,
a function, right?
Yeah. I mean, it's going to hang out if you say comma expression here and you extract it, for example. Or you do information expression on the model. But yeah.
Well, okay, but that's a different thing. And that, okay, so I don't believe in this, right? So you're saying this is basically for scoping. This is to say, what slot in here am I, accessing for my linear model? In this case, it is 100% irrelevant.
Yes, in this case, you could use another. Now we also support integers in there to represent symbolically how many inputs you have. Yeah. So this is a very fast way to generate degree 4 into variables. And this also works across the box. So you could say,
I'm telling you, this thing with variable names and scoping is a hack. It's a mess. It's wrong. Let's figure out how to get it right.
Fine, let's design.
Okay. So parameters means, in this case, that's the number of variables, but I could also have given
parameters in that case, you have another argument in the middle with 14.
I know. So this is, let me do 2 here.
You need variables. Yeah, you cannot have one mean both.
I don't understand.
You need to say comma x or something
and the
else.
blue stuff in the middle, you can see what Giulio has used.
But it's a stupid idea, because this should be a polynomial model. The variable is irrelevant, right? That variable is totally irrelevant. Right? So don't make people put it in. That thing there represents a polynomial model with 6 plus whatever it is. Wait a minute, why is it that way round? It should be the same way round, that if I take that polynomial, hold on, if I say coefficient list of the polynomial 8x squared plus 7x plus 6.
Wait a minute. Yeah.
Okay,
I stand corrected. It is the same way around.
We are using coefficient list internally to find the order. Is it the reordering of the evaluator that is displaying that? I have no control over that.
No, the issue here is has to do with
orderless.
For plus, but that's a different thing. I mean, that plus will get ordered that way, I think.
Exactly. Yeah. I'm saying the evaluator is reordering.
Why coefficient list is doing that. I mean, like from digits, for example, would do it the other way around. If I say from digits of %29, comma x, I'll get that, which is the other way around. See what I'm saying? Which is unfortunate. And by the way, that should be under possible issues in coefficient list and from digits. Can somebody make sure it is?
Man, thanks, because I didn't even know about this inconsistency.
I can make a report, yeah.
Okay, so here, this should absolutely represent the dissonant model that is, whatever it is, 8x squared plus 7x plus 6.
I'm not completely sold.
How do we indicate?
Are all broken.
So one of the big things that's hard in what we have previously is multivariate polynomials of some degree. So how do you indicate like I have a bivariate polynomial?
Well, whatever coefficient list does. You mean that it is bivariate?
Yeah, well, you can have total degree 2, and it's
I
2.
understand. I understand. So what we need is something like polynomial model. I mean, the thing you have has to work. Polynomial model, degree. Well, doesn't it have multiple degrees if it's a bivariate polynomial?
You could do both. You could have a vector of degrees, and you can have a total degree, a single.
Okay.
A total
right now,
degree.
right now we support total degree, but we cannot support vector of degrees.
That should be a vector of degrees. Right?
Yeah, we cannot support it. That's not difficult.
That's a formatting bug, but other than that.
So that's really nice to not have. That's tedious as hell to write out.
Absolutely. Absolutely.
You know?
I agree completely. That syntax needs to be supported.
Mm-hmm.
Let's figure out how to do that without this hack for variables. Okay, the most important thing, star model, the variable never means anything other than it is used only for internal construction. It's the same thing as in a lambda, right? If I put in, function x squared,
x squared,
it doesn't care what the name is, right? This is the same thing. Okay, so for example, in polynomial model, I would like to be able to say, I mean, I don't know why I need to even bother. Well, okay, I'd like to be able to just give the polynomial here. No, except I can't. I would like to be able to give the polynomial, Okay, somewhere, like it's probably not polynomial model.
No, this is nonlinear model. It works already, but you have to say nonlinear model, and it's gonna fit A, B, C. Yeah, the fact it doesn't display is a bug. It's fixed, but yeah, this is fitting AX2.
Okay,
blah, blah, blah,
okay. So let's try and understand the concept.
And interestingly, that's also a linear model, because if you give a list of x squared, comma x, comma 1, those are the basis functions. Do you know what I'm saying? The ABC come in linear.
I understand.
Okay.
But so this here has two dummy things.
Yes.
ABC is going to be fit and X is going to be fit. Right?
Yes.
X is going to be used.
Which again, incidentally, we have consistent syntax right now. So if you say polynomial model 2 and then list ABC, comma X, it also works. You just give dummy names to the parameters in case you want to refer to them later. This also works.
Why would you refer to them later? You can't refer to them later. It's an opaque container, like function. There's no way to get to them from the outside.
Yeah, because you can extract the parameter names, and you could, for example.
That's bullshit. You shouldn't be able to do that. It's like extracting inside a lambda to get its body. You shouldn't be able to do that.
Well, there are cases. For example, you might do the derivative the derivative with respect to a parameter to find sensitivity.
Yes, that's actually useful.
That's a real case. That's a complicated case. So now if I take this here and I say derivative of that, I have no idea what this does.
No, derivative works, but that doesn't. Because the function is not this does not have a free x.
Derivative
1. Yeah, 1, and then the function. That'll work.
Okay, so let's understand what the analog of that is here, because the same thing should work on these models. Right? Whatever parameters these models have,
derivative is not super practical. Like in these, we're going to have many parameters. This is not going to work very well.
Okay, but this idea that you can reach inside the lambda basically and pull out its bound variables is a really bad idea.
I think that there's one thing that we could do, which I don't know if we have reports that do this now, but even when you have a fit model, So it was useful to know what the sensitivity are for each of the parameters that you fit.
Sure.
If you have just a regular plain vanilla expression and you substitute in numerical values for parameters, you can never take derivative with respect to the parameters because they're gone in that formula.
Yeah, right. But okay, let's do a very basic thing.
Mhm.
So let's say I've done this polynomial model fit wherever I did it. Here, okay?
Mhm.
I want those coefficients out. How do I get them?
Information.
That's pretty horrible.
Yeah, but we decided
Pretty
early
horrible.
on the evaluation semantic for this is just for evaluation. You don't mix
Okay.
evaluation and property extraction.
Okay, what do I do here to get the coefficients?
Parameters.
Okay.
And if you say parameter rules, you get the name goes to what you expect. In this case, it's auto-generated, but another useful thing is that if you take time to write down the names, those could be
Where do I
names
put the
useful
names?
for you. Yeah, instead of polynomial model 3, you do polynomial model. In that case, you need 4 things like A, B, C, D, comma,
No.
A, B, C, D.
Here,
like
I
Yes.
say A, B, C, D.
Exactly, comma X.
let's say that you had a
Why do
growth
I need comma X? Why do
Same
I
as
need
before.
comma X?
Why you're getting
It's
angry over the same
wrong.
thing?
It's
Yeah, but
wrong.
you said that before. This is not what's implemented right now. You
Okay.
need to put comma X if you want to.
Where
to
do I
make
put
it
comma X?
after ABCD?
No,
Comma
it's
X.
before A, B, C, D.
No, why? It's never
okay.
that.
But this shouldn't need the X here. We agree, right?
I want to talk about that.
It can't need the X. The X is irrelevant. And why did it?
It's giving messages. Now, this is something we can discuss about this.
Okay,
The optimizers are going to
wrong. This is
Okay.
obviously wrong. You gotta deal if there are messages somehow from the optimizer, then package those messages up and say something that's relevant to model fit. Don't give some internal entry.
This is relevant. Do you see? This is an error message from model fit. You can extract them from the report, or you can click on polynomial and you get nice failures that contain the messages that the optimizer gave. If you have better ideas, I'm happy. But you said clearly that you don't want messages from another function.
No, I
with
don't.
a different head. So we need to find a way.
Messy.
Then we need to find a better way to package them, because I cannot give them as messages.
Well, okay.
Also, I'm not entirely sure why that is a problem, because it gave a fit, but yeah.
This is the mechanism we need to discuss. Oh boy,
I'm
sinking
happy
deep into this marsh. I mean, you've done a lot of things here, which are not ridiculous to begin with, but I think this needs a bunch more grinding. Okay, let's talk about. Okay, again, let's go back.
I mean, actually, so I mean, I sympathize, Stephen. Having variables hanging around is bad, generally speaking, because they get caught up in things. But knowing where your parameters are in a model structure like there's another name for these models. It's model structure, the ones that are not fit.
Like this is a fine thing. This is a very convenient way to specify it.
Mm-hmm.
Yeah, for small things, it's great.
Right. So the question that I have is, how do we elide that form in a good way without the silliness of having an X there when we don't need it? Right? So let's look at the cases where you're trying to put an X in. Okay, so something like this. That's.
I mean, I like that. I'm using that all the time. This 6,2, sorry.
Yeah, of course, that's good. I agree with that. I have no problem with that.
But then it becomes difficult to.
I know you haven't solved the problem. I got it. Problem is not solved. But the solution you have is not a good solution. So let's go through what exactly we're trying to do. Okay? So if I open the polynomial model page, will I see the syntax here?
Yes, degree bars or degree parse bars. And then there's examples below.
Yeah. This is the bad thing. This is bad. Having to have a third argument hanging out there is bad. So the question is, why do we need this? I don't understand what good that does us. The two argument form with the
It gives dimensionality to the model.
Yeah.
What do you mean?
If you want the bivariate polynomial.
What's the number of input?
There.
1, 2, 3.
Then put a 2 there. Why are you putting vars there? Some random variables that you never care what their names are. Why don't you just put a 2? Oh, I see. That's because that's a variable slot, and that 2 stands for 2 variables.
Yeah,
Yes.
that could be
Right.
is in
Okay,
place of
hold
x,
on.
y.
Hold
I have
on,
only 2.
guys. We can solve this problem. Okay? We can solve this problem without the hack of putting variables there. Okay, so what are the cases we want to solve? We need to solve, okay, I don't think we need to solve the problem of saying, you know, I don't like the fact that this nonlinear model thing, I mean, it would be nice if you could say here, you know, just like you say that in other cases, that you could give the formula explicitly if you wanted to.
Okay, if you allow me to have these 3 arguments, we can parse the first argument and figure it out. And we can even complain if it doesn't
No,
match.
I understand. But if this, so this would be a way, you know, I don't quite understand why we don't have a thing called something like formula model, where you can just give an arbitrary formula here. See? I mean, you can call that a nonlinear model, but I'm just calling that a model specified by a formula. As
Yeah,
opposed
we had this initially. We thought about it as an alternative name for nonlinear model. We could call it formula model. Nonlinear model is very standard, and people will know immediately what it is and how it is fit.
I mean,
whatever.
this formula model is even linear.
Yeah, so that's why I don't think we should call it. I mean, we should at least have formula model. We could have nonlinear model as well if that's a known brand. But this one isn't even nonlinear, right?
Right.
So formula model and nonlinear model could be essentially identical. But I think formula model is the general thing that will work. Okay, so given that we have formula model, anything that has explicit variables with names and so on goes into formula model. In polynomial model, you're dealing with things that don't have names. Like you want 6, 2 to mean total degree 6, 2 variables. Am I making sense?
Mm-hmm.
And there's nothing with names there. Now, what is the case where you find it useful to have names in polynomial model?
Almost never. Or I mean, it depends. It depends. If you unless you want the variables to have names that you care about, like yield and area or something like that.
Then use formula model.
Yeah, the only problem I see with that is that how do we fit a formula model? Right now, polynomial model is documented to be a linear model, and we fit it using least square, while a nonlinear model is not fit using least square, and there's clear distinction between the two.
But there's a fine automatic notion there where you can have a method, a fitting method or something option to this if you really want to. But most of the time, people are just going to want the best fitting they can get, which means if it's a linear model, use these squares. If it's not, use, I don't know what you're using, maximum likelihood or something. What are you using? Or some norm?
Whatever fine fit is using, I think, is like some minimization
or something.
Yeah, we have different norm functions and we have different regularization. I mean, that's, different norms.
Yeah, no, but I don't know the procedure that it's using, like probably something like n minimize with smart in serialization or something like that?
No, it's using
Or no?
a non-linear least squares
Okay.
for, when you use that norm. If you use other
Yeah.
norms, it will use other optimization functions, maybe convex, trying to be very efficient.
Okay, cool. But
Okay.
it's different from normal least square, yeah.
Okay, we're going to have to wrap up because we've got another meeting we have to get to. We need to pick this up again in the next couple of days.
I think this is an important discussion because it is the convenience, if you like, workflows, convenience. It's not the functionality, but it does affect the functionality. How convenient.
It certainly does, right? I mean, and I think that this reminds me a lot of the way we've done statistical distributions, which I believe has worked quite well.
Yeah,
Yes.
actually, that was my inspiration initially.
Right.
Yes.
I mean, we could have put all kinds of variables into our statistical distributions, but we didn't. See what I'm saying? It's just normal distribution of,
I mean, we have much
0, 1.
richer statistical distributions what you're talking about are parametric statistical distributions. They have just a few parameters.
Yes.
Okay.
But that's what we're talking about in these models. I mean, they're
Well,
we have much richer distributions than that.
Just to get an idea. Yeah. Just to get an idea of what's in the word here, like open types. So you get an idea about kind of a big picture here.
Formula model is a better name for this. I mean, we can support nonlinear model as well, but nonlinear model would force it to go to this norm way of deciding about the fit, whereas formula model would be automatically switching different methods.
Okay.
And linear model can be automatically, can be forcing it to the linear form.
Yeah, linear model, I think the list is fine.
I think you should, just as a detail, I think FineFit already does auto-recognize that, but you should check. See what I'm saying? It knows if it's a linear model, it will use a better method.
Oh, okay, interesting. I'll check, yes.
I think we should have this. I mean, again, this shouldn't be an argument. Only in the case of formula model or these ones that have, I'm not even sure this is quite right. Okay.
Why?
Maybe that's okay. But formula model is the thing that we should advertise the most. That is just you type in the formula and it just fits to that formula. Okay. Everything beyond that, is a courtesy. Like exponential model, no X there.
But you can see exponential model 1 or 2, and it's going to have the same effect, yeah.
Well, 2 means to bivariate.
Exactly.
Model. Yes. Okay, yeah. Fine. But what I'm saying is, never use named variables except in formula model.
Okay, yeah, but I mean, was trying to say, for the sake of this example, exponential model 1, power model 1, we will have the same effect.
Right. Now, there's an argument order question for polynomial model.
Yes.
Because, there's the number of variables and there's the degree.
No, I think degree should go first because hyperparameters, they go first in every model. I wouldn't like to switch only for a single one.
Where's the hyperparameter in the okay, we need to go to the other meeting.
You see, nearest model has neighbors as a default hyperparameter, which is 5, yeah, for example. Great. But you could say neighbors 5. Decision tree has max step as a default, but you can use the association to specify all the one that you see here. Neural model, you wanted different names, so I put some proposals here. I don't know if you quickly one of them you like, we can pick one. Because this is the multi-layer perceptron. So you found neural model to be too general.
It's way too general.
And then here I propose either MLP model or multi-layer perceptron model, or we could elide multi-layer, say, perceptron model. Another one that came to me while I was preparing this and I forgot to put is feed-forward model. They are all the same thing.
Well, there's lots of feed-forward things that aren't perceptrons.
Yes. This is why I know my preference would be one of the three above.
Perceptron model just sounds very 1950s.
Potentially, yes. Could make a revival.
I don't know. Let's pick this up next time. Have a think about, let's devariabilize wherever we can. Am I making sense? Don't give names.
Basically, just as a kind of wrap-up concept, you have basically two classes of models. The one where you don't care about parameters and variables, like decision trees and k-nearest neighbors and neural networks, and you only care about the first argument, hyperparameters. The rest you are never gonna, you can specify if you want, but it's never done in practice. And the one that are more like formula style, where you might care either because you have to, like to kind of specify what is dummy in another, or because you want to name them. Again, like price, amount, area, things like that, yeah? And people like to do that.
Well, you might want to name them in a decision tree as well. I got to go.